The general title for this lecture is The Existence and the Proof by Contradiction. But we need first to show the difference between how to prove and how to disprove. First, I'd like to provide an important point regarding the quantified statements. If I have a statement like this one, there exists X belongs to some set, let's call it R, P of X. Here, this P of X is depending on this X. And now we need to negate this statement. So the negation of this statement, negate of there exists X belongs to R on condition P of X, this equivalent to the negation of there exists is for every X belongs to R on condition the negation of P of X itself. What if we have statement for all X belongs to R, P of X? The negation of for every statement is equivalent to the negation of for every, just to provide an example, by there exists X belongs to R on condition that the negation of P of X. So based on these points, we need to show the difference between how to prove and how to disprove. We know before how to prove, and what about the techniques of proofs? Okay, but regarding the disprove, in mathematics, we sometimes need to prove that in something does not exist, or in something is not possible, or in something is wrong. For the proof, on the short run, we have two types of statements to prove. For every and there exists. To prove for every, so you have to provide a full proof using any of the four techniques that we covered before: direct, contrapositive, vacuous, and trivial technique to prove a statement with there exists. So just to provide an example. While for the disprove, we have two types of statements. Disprove statement with there exists, disprove a statement for all. To disprove a statement with there exists, so just to provide a proof, there exists, its negation. So for every, which is just a proof, provide a proof. But regarding for every, here we have two ways to disprove a statement that's starting with for every. The first way is to prove the negation, negate the statement, and then prove this negation. The second way for disproving a statement that's starting with for every is there exists counter example. Just to provide a counter example.